We're going to jump right in here. We're going to talk about the document object model today. I'm going to refer to it as the DOM. Hopefully everybody knows what that is. Out of curiosity, how many designers do we have in the room? How many developers do we have in the room? Okay, interesting. So my name's Cody Lindley. You might know me. 6 years ago, I created a script called Thickbox. I was one of the original jQuery team members. I masterminded the jQuery cookbook. I've authored a set of books called Enlightenment, JavaScript Enlightenment, jQuery Enlightenment, and soon to come DOM Enlightenment. You can find out more about me at codylindley.com. These slides are actually live and available. You can follow along with me as I work through these slides at /domit. So you're not going to offend me if you have your computer open and want to play around as I'm playing around. If you walk into a bookstore these days, you'll probably find a stack of JavaScript books about this high, and you'll probably find a stack of jQuery books about this high. In the last 12 years, you will find one book written about the DOM. Has anybody read it? It's old. 2002. Yeah, it was actually a pretty good book for the time. But people have, in micro ways, talked about the DOM, but no one's written about the DOM. No one's talking about the DOM. So why is that? We'll let that stand as a rhetorical question for now. In 2006, Douglas Crockford, when speaking to Yahoo, called the browser, DOM, a vast source of incompatibility, pain, and misery. 2 years later, John Resig, also speaking at Yahoo, stated that nearly every DOM method is broken in some way in some browser. So clearly it was a mess. Is it still a mess today? I'd like to assert that the mess is not as messy as the mess once was. That if we're looking forward instead of back, there's actually more good than there is bad. So, DOM-it. We're going to talk about the DOM today. We're going to talk about the native DOM. And this talk's broken into two parts. We're going to do a little bit of a history lesson, all with the intentions of some healing, some forgiving and forgetting. And then we're going to embrace by looking at actual native DOM methods and properties, nodes. So we're going to go back in history a little bit, and we're going to talk about the browser wars. For those of you, is there anybody here when I say browser wars that has no clue what I'm talking about? Okay, interesting. So in 1997, Microsoft and Netscape were in this war, and they were fighting for market share. And the market share they were fighting for was in the browser arena. And Microsoft released Internet Explorer 4.0 in 1997. They had this big launch party. And that's what that E is in the background. And it was kind of a joke for them to take this E and put it on Netscape's front lawn, and then Netscape knocked it over, and they put their mascot on it, and there's this rivalry. And the browser wars were very much about competition. They weren't about standardizing. And these people were competing against each other. And the weapons that they used were APIs like the DOM. They were trying to outdo each other. They were trying to one-up each other. And these APIs were the weapons. And the DOM was one of them. Several years later, the war ended. And sort of the aftermath of the war left DOM implementations in this sporadic state, and everybody implemented things differently. We didn't have the W3C, in the early 90s or the late 90s telling us what the DOM should look like. So, the war ended, and they're trying to move in this direction of standardizing and get along. And by the way, does everybody know who won the war? By 2002, Microsoft had 95% of the market share. In 1997, Netscape had over 90%. So they crushed them fairly or not fairly, depending upon how you judge the lawsuit. But standardizing is a complicated and timely venture. It was hard not only on developers, it was hard on the browser vendors. They're trying to figure out how to standardize stuff, Developers are trying to figure out how to develop when they have multiple APIs to develop against. But if we fast forward a decade, and we're talking 10 years, right? So 10 years seems to be this perfect amount of time for things to get better. And now we're at a different place. The browser wars are far behind us, and now browser vendors aren't working against each other, right? They're working with each other, and they're in a friendly competition of how fast they can standardize. How quickly can we get to the standards the W3C are creating? And it's sort of a different world that we're in now. And because of this, modern browsers are more alike than not. I mean, if we really look at the specifications and we look how the browser vendors are implementing them, we're in a good place. It's more good than bad. So I'm suggesting that we looked at those quotes from sort of the thought leaders in the JavaScript area, and they have a negative perspective, and maybe they still do today. But we need to forgive and forget the past and look forward. And we can do that, I think, by embracing native DOM. So we're going to talk modern DOM. And when I say modern DOM, I'm talking about DOM implementations in modern browsers. So that's IE 9+, the latest version of Safari, Chrome, Opera, Firefox. So we're going to start with a very simple question. What is the DOM? And unfortunately, I crafted this definition. I'm going to read it to you halfway. And it's not very pretty, but the DOM is a specification for describing an HTML document, how an HTML document can be parsed into a structured tree of JavaScript node objects. So that's pretty boring, right? How can we? Interesting. Sorry about that. So definitions are pretty boring. I'm just going to show this to you. What I have here is a text input, and right next to it I have an iframe. And all I'm doing when I click this parse button is I'm parsing a structured tree of elements into an actual node tree. So I click that over here in my iframe. You can see if we look inside this iframe, we've created a document node. We have a doc type node. We have an HTML element node. And this is the DOM, right? We take a structured HTML document, we parse it, the browser parses it, and it puts it into a tree. And we're using the web developer tools to identify that tree. This is the DOM, right? So the next part of this definition is for the purpose of scripting the document and its nodes with methods and properties. How many people use developer tools here? Everybody? Cool. My favorite part of the development tools was when I discovered that if I select a node out of the DOM tree, and here I'm selecting the document, and I look over into this properties pane, this is actually telling me all the methods and properties that are available on this document node. So has anybody tried to read DOM specifications or find DOM API guides? It's next to non-existent, right? I mean, Mozilla provides a little bit of this, but in order to find the methods and properties that are available to DOM nodes, all we have to do is select it out of the tree and look through this properties panel. And the beautiful thing about this is the DOM is kind of mysterious because you start wondering, where do these methods and properties actually come from? Well, this outlines it for you. It's telling us that there's a document node. It's an object. It inherits from an HTML document interface, which inherits from document, which inherits from node, which inherits from object. And of course, inside of each of these, it tells us the properties and methods it inherits. This, if there's one thing you get out of this talk, it's this, that the DOM tree is made up of node objects, and those objects have methods and properties. And you can find out those methods and properties very easily inside the inspector. How many people knew that? How many, am I telling you guys? Okay, so the next question you might be asking yourself, now we've got this idea of the DOM tree. It takes HTML structures, it parses it, it creates node objects. So the next question is what type of node objects are we dealing with here? And the simplest way to get at that is to use this keys command in the console. We're going to inspect the node interface. And here it's just going to list them out for us. And as you can see, we're dealing with a handful of different node objects that kind of end right here. There's a lot there, and when people first start looking at the DOM, they get intimidated by this list. But some of these are obvious, right? Element node, attribute node, text node are the first three. These aren't too hard to translate into what we know when we write an HTML document. These particular properties on the node interface, they're just constant values, for those programmers. That's why it's all in uppercase. So if we ask what the values of each of those properties are, we get a numeric mapping, so to speak. So element node is equal to 1, and attribute node is equal to 2, and text node is equal to 3. These are just numeric mappings. So instead of having to type out element node, we know that if I get a 1 back, that I have an element node. So what that would look like is, if I grab the body element, and I ask for the node value, oops, not the node value, the node type, I'm going to get a 1, right? Because the body is an element node. Does that make sense to everybody? Yeah, great. So this is all just to say that when you see these numeric 1, 2, 3, 4, it's just referencing a type of node. Okay. So instead of looking at a bunch of different nodes today, we're just going to look at the nodes that make up the majority of an HTML document, which are the document node, an element node, and a text node. I mean, these nodes inside your HTML documents make up 90% of the document, right? If it helps you to think of this in a way that isn't JavaScript, we're talking about the document object that we know of in JavaScript. We're talking about elements, and we're talking about text inside of elements. If you only think in jQuery, we're talking about the fact that you can select a document, that you can create elements, that you can create a text. No, does anybody realize that you can't, in a clever way in jQuery, create a text node? Has anybody ever tried to do that? So anyhow, we're going to look at 3 nodes. But I have a question. What is the first node in the DOM tree? Is it the HTML element, the doc type, or the document? Does anybody want to try to answer that? Yes, it's the document. Did everybody know it was the document? I'm amazed at how many JavaScript engineers didn't know the answer to this. But the document itself is a node. So if we're looking at an HTML document in our editor, we see a bunch of nodes, but let's think of the white or whatever background you have in your IDE. That is a node too. It's where the node tree starts. It's the document. So we're going to look at a document node. And again, this is just a text input. And all I'm doing when I click parse is parsing the text string in that text input and shoving it in an iframe. OK, so if I click parse here on a blank document, what am I going to create? Anybody? Yes. Every time we load an HTML document into a web browser, even if it's blank, it creates a document node. And in fact, if we look inside this iframe, it not only creates a document node, it creates an HTML, it creates a head, it creates a body. All I did was load an empty HTML page. So a document node is always created. A document node is in the tree. You know, we can Does anybody know what this gives me? Document.firstChild? Yeah, very good. So if I try and grab the parent element here, what am I going to get? That's right. Oop. I'm in the wrong page context. Well, anyway, sorry about that. So what we've gone over so far is the fact that we can create a document node by simply loading an HTML document. It's always created. It is also possible to programmatically create an HTML document. So in memory, we can create a document. And this does the same thing. Chrome actually adds the doc type for us, but create HTML document. Who's here familiar with the document fragment? Okay, so programmatically, we can create these documents. When we load an HTML page in a web browser, it does it for us. We can also use document.implementation.create HTML document, and we get the same thing. So we could create multiple documents in memory. The one that's being viewed is the one that's loaded into a web browser. This is still a document node. So we've looked at creating document nodes, and we're going to look at a couple of properties. Sorry, I know this is tough to see. Can everybody see that? Active element, doc type, doc element, head, body, default view. Okay. So these are a couple properties and methods of the document node. And again, remember I showed you how you can see all these in the console. It's also worth saying that you can also see all of these in the autocomplete. So if you're ever working with the DOM and you're like, I wonder what a document node has available to me, you can open up the developer tools and just scan through all the autocomplete. And this will tell you the properties and methods available. It's because we don't have documentation for the DOM, this is how we have to do it. But there's a couple of these that are really handy. So we have active element, which right now the active element in this document is the body. If I select a text input and I run it again, the active element is the text input. Might be handy, might not be. We also have doc type, which is a reference to the doc type node, right? And we have document element. This gives you a reference to the first element node in a document. These actually become pretty handy when you start thinking about scripting documents. I want a shortcut, to the HTML. I want a shortcut to the head element. All these are available, and you'll see me use body a lot today, off the document node. You can also get a reference to whatever the document is being viewed in. So, and these names aren't great, right? Like you have to memorize some of these names, but default view gives me a reference to the window. Some of this stuff becomes pretty handy when we're dealing with headless DOM. So that's the document node. I'm curious how many people have thought about the document as a node. Have you guys given this a lot of thought, or no? Yeah. It is a node. You should think of it as a node. It's part of the tree. The next thing, and this will be what everybody else is more familiar with, are element nodes, right? So I searched the web for the best reference I could find on elements, and it's in the HTML Living Standard document. But if you're ever wondering how many elements are available, this is a pretty handy reference, and you can find it in the slides. But this actually tells us what attributes we can put on element nodes, what interface they come from. It's extremely handy if you have not seen it before. It's linked. So if you go, it's the HTML Living Standard. Who asked the question? Yeah. It's just linked. You can find it on here if you go to the slides. I can get you the slides after. So again, we're talking about creating element nodes. So if I parse this document, of course, head, body, UL, HTML, it's going to get parsed. We're going to create element nodes. You're going to see them in the DOM tree, right? Here we have those nodes. Additionally, just like the document, we can create elements, right? We are not left with relying on the browser to parse an HTML document to create a node. We can, in memory or programmatically, create nodes as well. So that's creating element nodes. By the way, you can go back through. I set up this presentation thinking that if people really wanted to investigate the native DOM, they could go back through this presentation and use this parser and play around and open up the inspector, just like I'm doing. So element nodes. We're only going to look at 2 methods and properties on these, and I'm going to grab the body element and show you owner document. So this is pretty handy in that any element I grab out of the DOM tree, if I ask for its owner document, it's going to give me a reference to the document the element is contained within. So let's see here. I don't think does anybody know how to do that? I knew that. Yeah, I didn't think I could dock it to the top. Is that better? No, I can't keep the browser in presentation mode if I do that. Sorry. What's that? Is everybody having trouble seeing it? Thank you. Where did she go? For saying something. Is that better? Let's see. So you guys could not see that. Is that the case? We'll keep going. I'll come back to anything you want. How about that? What's that? They actually are. They do scale. So owner document. Hopefully you guys can now see that. And of course, a pretty obvious one is tag name. And this just is a property that gives us the tag that we're actually on as an object right now. So there's a whole, there's 50 methods and properties, right? And we can go and find these on element nodes. Because we're talking about elements, we have to talk about attributes. And previously in the DOM specifications, attributes have been considered nodes. But if you think about it, an attribute isn't part of a node tree, but yet we still consider it a node in the specification. In DOM level 4, they're actually going to remove the inheritance associated with attribute nodes on the node interface, so it's no longer considered a node, even though you can't select an attribute in the tree, right? We can't traverse to an attribute node. So eventually, we're no longer going to call them attribute nodes. They're just going to be attributes. So here I call them element node attributes. But everybody's familiar with an attribute on an HTML element. Native DOM gives us a couple of really handy properties to deal with these. And if I grab my body and I ask for all of the attributes, I get this fancy little list. And this is, of course, here we go. So we've got our body element up here. And I'm grabbing all the attributes off of it. And it gives me this list of my custom data and a class and a style. And that's pretty handy to get a list. But we also get these get attribute, set attribute, has attribute, and remove attribute. I mean, all these are pretty obvious, right? This just gives me the ability to add any attribute to any node I want. And then we get a little bit more specific. Now we have the ability to grab the body element and get a class list. And what a class list is it breaks down all the class substrings in a class attribute. So if we look up here at class, we'll see we have a class of boo and a class of goo. And by grabbing a class list, it breaks those down into a list, an array-like list of boo and goo. So this is pretty handy. We can add, we can remove, we can toggle, we can contains. This is all native DOM. So that's pretty handy. We also have available this data set. What this data set does is it gives us an object that contains all of the data attributes. So you see my data, my own attribute. Well, if we look down here in this list, we have my own attribute camel-cased for us now with the value of foo. So this just gives me the ability to grab that value. So again, these are newer native DOM things that are going on in modern browsers that we don't need a library for. Not very many people are aware of this one, but we can grab the body element, and we can, of course, grab the style attribute, but we can also set properties on that. A lot of what I'm showing you here, we use jQuery for today. And we should, right? We should use jQuery for this if it makes our life easier. But if we don't have jQuery available to us, or we need to do something light and quick, or we're on a particular device where we don't want the overhead of a DOM library, knowing this stuff could actually be pretty handy, right? Yeah. Modern browsers. IE9. So when I was saying before, when I say DOM implementation in modern browser, IE9 and latest. So really, quite honestly, all you care about is IE there. As soon as you drop below 9, some of this stuff is available, but it's not all available. If we're talking modern browsers, everything I'm showing you pretty much works. OK, so the last node we're going to talk about, we've talked about document nodes, we talked about element nodes, we're going to talk about text nodes. And text nodes were that thing several years ago that everybody sort of tripped over as soon as they started working with the DOM. And that's because not very many people expected a text node to actually be a node. So really, when we say text here, what we mean is anything we can type into a keyboard. So if I hit a return in an HTML document, that's text node. Anything I put in my HTML document, when it is parsed and put into a structured tree of nodes, becomes a node, including anything text-wise. So of course, if we parse this, we get a text node. If we look in the tree here, what you'll see is a text node, and we know that's text node because it's coming from the text interfaces over here. And then, of course, we have an element in there, so then we get an element node, and then we have another text node. It is also possible, just like with document and element, to create text nodes. So we have the ability to let the browser parse our document and create nodes. We also have the ability to create them programmatically and in memory. I'm going to just look at two properties again. There are many, but if we grab, so I'm going to switch frames here. I'm going to grab this frame over here in the inspector, and grab body. I'm going to grab the first child. And remember, what's the first child in body now? What's that? That's right. So here's my text node. If I ask for the data on that, it's going to return to me a string. There's actually a whole set of methods and properties to work with text strings. Has anybody ever wondered how to work with text strings in jQuery? Is anybody aware of any method in jQuery that works with text strings? There's one. It's called contents, but not very many people use it. So another handy property in here is this text content. And if you'll notice in this document that I created, we created one text node, then we had an element node with the strong, and then we had another text node. And so in order to get all the text in the body, I'd have to concatenate two nodes together to get one string, right? Well, text content does this for us. So by using text content, it went into the body, and it grabbed all the text nodes out of that and concatenated it for us. Pretty handy method. So okay. To review, we've got a structured tree of nodes. That's what an HTML document turns into. We looked at a document node. We looked at element nodes. We looked at text nodes. The next thing we're going to do now that we have this mental model of what nodes are and how we get the nodes from our HTML documents, we're going to look at the native DOM in the way that jQuery looks at it. And so, I was on the jQuery team, and back in 2007 and 2008, we came up with this idea that jQuery is just about finding something and doing something. Like, that's how we want it to explain jQuery to everybody. You find something, you do something. This simple idea, in my opinion, is what made jQuery so popular. So I'm just going to, if you can shift your mind to jQuery, but think about it in a native DOM way, that's what we're going to do now. And that, of course, involves finding nodes. In jQuery, this is the basis of jQuery, right? I'm going to find all of the anchor elements in, let me switch frames here, back to my top. So I'm going to find all the anchor elements in this document. Of course, gives me a list, right? Well, there's native methods to do this, right? We don't have to use jQuery to create these lists. So we can go in here and grab something like get elements by tag name. That gives me the same list, right? It's the same thing that jQuery is doing. It's just giving me a list. Get elements by tag name, that's not as handy as jQuery because we can pass jQuery a selector, right? So you can do the same with query selector all. So this is pretty much what jQuery is doing, right? I'm passing it a selector. I want all the anchor elements. It's giving me back a list of all the anchor elements in the document. Now I have my list. I have my find something. Has anybody ever wondered which CSS selectors are supported by query selector all? Maybe I'm odd. I randomly found this W3C test that actually tests every one of these. So every level 3 selector, they test in Query Selector to determine which browsers support it. And surprisingly, except for one variation, they all do. So there's actually a good deal of support for native Query Selector All and selector expressions. So that's finding something where we pass it and tell it what we want to find it, just like jQuery. But there's all these pre-selected lists. And this really doesn't exist in jQuery, but you know, this is not really that complicated of a thought, right? It's you know, that would give me all the images if there were images in this slide presentation, but there aren't. But if I want a list of all the scripts, right, this is a pre-configured list of all the scripts in the page. It's just a list, like jQuery gives me back a list. So this is your find something, just like the jQuery function. Before I go on, I'm going to talk a little bit about these lists that you get back. How am I doing on time? I'm done? Okay. So very quickly, there's these lists that you get back. All of them are live, except the Query Selector All. And all this means is if I grab one of these lists and then I update the DOM, that update will show up in live lists. It will not show up in Query Selector All. I've got a minute here, so. You know, all that was left in here, and you're welcome to continue to look at these online, but you know, the next part of jQuery basically was iterating. And we don't need jQuery to iterate, right? We can come up with a really quick way to iterate over a list. You can find specific references, not just create lists. We can do contextual selecting. Each of these Query Selector All works off elements. So just like passing in context a second parameter to jQuery, we can also select an element and then do a sub-selection, which is really the context. So again, with this idea, now we're at the doing something part, where all of these properties and methods native to the DOM are available. These that are flashing, these are DOM 4. They're coming. So these methods that you're used to in jQuery are going to become native. And then, of course, text nodes, we have methods and properties. jQuery doesn't offer this, right? So I'm done, but don't send me any hate mail. Don't call me names on Twitter. I'm not telling you not to use jQuery. Use jQuery. Just make sure you have in your tool set the ability to use native DOM and understand native DOM. Really quick, I wrote the next book on the DOM. O'Reilly's going to release it. There's some links here if you are interested in native DOM. Thanks, guys.